Welcome to this quick explainer on tightly coupled versus loosely coupled system in computer architecture. In this video, we'll understand their structure, behavior, and key differences with simpler examples. So, in multiprocessor system, coupling refers to how tightly processors are connected and how they share memory and resources. Based on this, we classify the system as tightly coupled and loosely coupled. Now let us understand first what is tightly coupled system. Tightly coupled systems are systems where multiple processors share the same memory. That means we are having the shared memory. The processors are connected via high-speed bus and work closely together. Communication is fast since everything is centralized. So we have fast communication in tightly coupled system and a shared memory. For example, a dual core CPU. A dual core or a quad core processor in your laptop or smartphone is tightly coupled system where all cores share the same RAM. That's a random access memory. Next we have loosely coupled system. In loosely coupled system, each processor has its own local memory, separate memory, and it communicates with each other over a network. So we can say that it's a network based communication. The systems are also called as distributed systems. Though the communication is slower, the system is very scalable and more fault tolerant. For example, a server farm or a cloud infrastructure like Google Cloud or AWS, where multiple machines work together and each machines are having their own memory. Now let us see the key differences between the tightly coupled and loosely coupled system. So here is a quick comparison. Tightly coupled system, they use a shared memory, while in a loosely coupled system we have a separate memory. Communication in tightly coupled, it is used by bus, so it is fast. Here it's in loosely coupled, it's a network based, so comparatively it is slow. The system type, that is centralized in tightly coupled, whereas distributed in loosely coupled. The cost of tightly coupled is quite high as compared to the loosely coupled system, whereas its cost is low of loosely coupled system. The reliability, if we talk about the reliability, so reliability is very low in tightly coupled system because a single point failure, so it's not that much fault tolerant, while in a loosely coupled system is highly fault tolerant. For example, I already gave you that multi-core CPUs, quad-core, dual-cores, that CPUs that are tightly coupled system, and cloud servers like Google Cloud or AWS, right, that are loosely coupled system, right. In a real life, I can give you the example like if you are thinking of a tightly coupled system, so they are as a sibling sharing a single bedroom. They constantly interact with each other and share everything day to day, right. So that's we can consider a tightly coupled system, whereas loosely coupled systems are more likely like your friends, right, living in a different house. They all are having their individual house, individual rooms. In that they have their own things, right, but they are talking over the phone. They work together, they collaborate for the things, for the projects, for the games, everything they collaborate, but they work independently, right. So that's a key difference between tightly coupled and loosely coupled system. So if I summarize that, so tightly coupled system, it offers speed and efficiency, but it can be less fault tolerant and expensive, whereas in loosely coupled system they are like scalable, reliable, as it has more fault tolerant, but it has a slower communication, right? So you need to choose based on your application needs that what kind of couple what you are going to use, whether loosely coupled or a tightly coupled system. So that's all from my side. That's a quick explanation of tightly and loosely coupled system. Thank you very much. I hope you understood it.